Welcome back. So solving equations where your unknown is somewhere within a log. So you can see this example right here, which you might say, how am I going to solve this? Now, if you're studying functions, you may remember you can take the left-hand side of an equation and make that a function, in this case a function of x. Plot it on a graphing tool, maybe like Desmos. Then you can take the right side of the equation. In this case, it actually would be just a number because it's log of base 5 to 25. Plot that, and the intersection between those two functions, left-hand side and right-hand side, is going to tell you what the answer is. That's a visual representation. It's kind of like plotting lines and finding the intersecting point, right? So you do that with functions. But what if you wanted to actually know how to solve these and you don't have a graphing tool? Because that's often a very useful thing to know. So you have to keep a few things in mind. But once you've studied logs, kind of the introduction to them, I'll put up a link up above to the introduction to logs, so you should know what those are before you attempt this. Now, the other part is you may want to know some properties of logs. And those properties are also very useful. So I'll put up a link to the properties that I'm going to utilize here, because I'm going to be solving equations and I'll do it through examples to show you how to tackle these throughout. Now, before you start solving, which is what most students will do, they'll just try to dive in. Students will forget that when you are using logs, and this actually is true for also other equations, you also kind of have to be mindful of thinking about when you're solving, are there some answers that just simply won't work? They're just not admissible in any particular way. And with logs, that certainly is the case. So you may recall that if you take log of any base of x, so let's say, this is our function, so f of x, or sometimes, people will write it just simply as y is equal to, we know that whatever is right here, so whatever we're taking the log of, this, by definition, has to be greater than 0. And again, if you don't remember why, watch that introduction link that I told you just before. Now, we also have the assumption that our base b is always greater than 0 and it's not equal to 1. And that's also to do because logs are just inverses of exponential functions or of exponents. So if we know this, then we have to keep this thing in mind, that whatever we're going to take the log of has to be greater than 0. So for instance, what I mean is if I take this first right here, before I start solving, I'm going to duplicate this, I'm going to bring it here to the bottom. I will try to ensure that I know what I cannot have x equal to, because if I get that answer, then that means it's just not an admissible solution to my equation. So for instance, here I will know that 2x plus 1, because it is taking the log of that, this has to be greater than 0. And if that's greater than 0, now if I move things around, so what I'm going to get is that x has to be greater than negative 1 over 2, if I solve this inequality right here. So all my answers have to be greater than negative 1 over 2. So for whatever reason, if I would solve this and I get an answer which is kind of less than that, then that's not an admissible answer. Now, the other part that I have to look for is well, here I have another log. So I'm going to copy that because this also restricts me. And the restriction on this, now this restriction tells me that just x, so right here, x has to be greater than 0. So notice between the two, so between this right here and this right here, I already know that all my answers have to be positive, right? Well, the bigger one is 0, okay, so 0 is bigger than negative 1 over 2, and based on these, okay, my x has to be greater than 0 for this particular equation. Now, on the right-hand side, I also have a log, but there is no x, okay, that I'm going to be taking. This is just log base 5 of 25. That's just going to be a number. So always make sure before you start solving your equations and utilizing properties and so on, check what x cannot be equal to. So that's kind of the first step that you do. And I'm going to do that for all our examples. All right, let's dive into the examples, okay? So here is my first example, and I'm going to take them one by one. Now, it says round answers to the 10th if necessary, so we'll worry about the rounding after. Your teachers might tell you to round to other things, whatever. So I'll leave the rounding for you to worry about. So here's my equation. Now, for this, so my first step is always just check what x cannot be equal to. So right here, so from here, so I'm going to say 2 minus x. So this has to be greater than 0. All right. Now I'm going to bring, I'll bring my x over to the other side. So I'm going to get 2. Okay, so I have this. So what does this tell me? Well, this tells me that x has to be less than 2. That's what x, in terms of the domain for that, it's independent of what the base actually is. But that's what we're going to have to try to look and see. And if I get answers that are within there, then unfortunately they're not admissible and the equation is not solvable. So let's try to see what happens here. So how do I solve this equation? So now I want to get rid of the log itself. And this is where we're going to be using the property. So for that property, I'm going to paste this back in here. So what I'm going to do is I'm going to, raise both the left-hand side and the right-hand side. Okay, I'm going to use the base of 3. So this is what I'm going to do. I'm going to say 3. Now I'm going to raise this log. 2 minus x equals to 3. So I've raised the entire thing, the equation. Now, why am I doing that? Because I'm using the property, right here, because this property tells me that 3 raised to log of the base 3 is nothing else but simply now just 2 minus x equals 2. Now, this I'm going to just leave for the moment. So this is just some number, right? This is 3 to the exponent of 3.5. So it's going to be some number, right, that I'll have. Now, solving this, I'm going to now switch the 2 over on the other side. So I'm going to get this. It's going to be minus 2. And then I can divide by -1 on both sides, or multiply by -1. So this isn't anything new in terms of solving. So I'll just divide both sides by -1, and I get my solution. Now let's take a look and see what this gives me to see if it's actually an admissible answer. So I have 3, and this is raised to the exponent of 3.5, minus 2, so whatever that is, so that's 44.76 and so on. And now that answer, so whatever that answer is going to be negative because it's divided by. Now, it says, round to the 10th. So I'm going to round this to the 10th. So 44, this is 8. And now I have to check and go back. Is this an admissible answer that I have? Yes, it is, because x is supposed to be less than 2, and this is clearly less than 2. Now, what I'm also going to show you is, as you're solving these, so just to, again, and kind of get the gauge with functions, I'm going to just show you that you can graph the left-hand side and then the right-hand side, as functions, and then see where they intersect, and then we should get the same answer. Just so that you get intuition to what it actually means to solve any equation for that matter, if the equations are not necessarily just linear, like lines. So let me pop up Desmos. All right, so here is Desmos. So let's try to plot the left-hand side and then the right-hand side as well. So my left-hand side, I'm going to go into functions here. I'm going to go to miscellaneous and log. I need it with a base. Now my base is 3, so don't forget that, because if you forget it, you might get it wrong. And this is 2 minus x. All right, so that's what I have there. That's my first function. Well, hold on a sec. So let me just blow it up here. And now my second one, well, this one, in order to put in the constant of 3.5, so I'm going to put y equals 3.5, not 35.5, okay? And so first, you know, I would want you to see that that log, notice at 2, so here, right, it kind of goes straight down because it doesn't exist. And that's what I was referring to, that, you know, we definitely have x which is less than 2. And now let's see if these two actually meet at this, you know, negative 44 or somewhere there. Well, it does look like it's meeting somewhere over here. I don't know if it's that. Yeah. Okay, so there we have it. Okay, so that's the point that we have of intersection between the left-hand side and the right-hand side. So that's the intuition, right? But in order to solve it, now you have all the tools you need. You know, once you're kind of in grade 11 and you start and you finish up with exponentials, you know, you do the log properties, now you can start utilizing and solving these things even without graphing them out. But here I wanted just to show you, you know, that example. So here it is kind of blown up. Okay, so if I do that, you know, that's the example between them. Okay, so it's graphing them out on decimals. Okay, let's take a look at example number 2 that I have here. So I'm going to grind away through all of these. I'm not going to plot them all. So this example is actually the one that we kind of started off with. So this right here. And notice again, first thing, so we have to worry about, you know, this and this. So we do have to have restrictions. Now I've already done this in the beginning. So we said that this was supposed to be x, and it is greater, okay, than negative 1 over 2. And then from right here, we had that x has to be greater than 0. So this one dominates. So that's what we have to be careful of. Now I can start solving this. Okay, so what I notice, okay, when you're going to be solving these, you want to be able to combine your logs in some way by utilizing the properties of logs. So because I have a plus here, I have the same base right here. So then this really, okay, just means that this is going to be a log of the 2 multiplied together. So it's going to be the multiplication of x and 2x plus 1. This is of base 5 equals to log of 5 of 25. Actually, this, okay, so notice log of 5, this is 5 to the 2. So really, this just equals to 2, okay, from the log properties. Okay, so we know that. So that's what I have right here. And now, so again, the same trick as before. Okay, I'm going to raise everything. So I'm going to take the base, the same base always as your log. I'm going to say log of 5, okay, of, this is x, 2x plus 1 equals to actually 5 of 2. So that's of both sides, which is going to give me now x. 2x plus 1 equals to, actually, so here it goes, it's 25. And now I have to solve for x. Well, it's not going to be so easy to solve, but what I will do is, this is going to play on your understanding of quadratics, right? Because if I distribute this across, I'm going to get 2x squared plus x equals to 25. So really what I'm solving is a quadratics problem. So this is 2x squared plus x, I'm going to bring this over to the other side, equals to 0. And now you can use you know, any method for solving quadratics, right? So you're finding really the zeros or the roots of the equation. Now that we have this quadratic equation, we just basically can use any method we like to try to solve for the roots of it. Now, I probably encourage you just to take the quadratic formula and don't waste your time with like decomposition or something, but you can if it pops out at you right away. I'm just going to use the quadratic formula. So I'll do it in fast forward fashion. All right, so there you have it. That's our answer. Now we have to be careful because we're going to only take, there are 2 roots here, but we only can take the positive root, and that's coming from our restriction that we had originally, okay? So this right here. And so for that case, I can't take the -1 minus the square root of 201. I'm going to take -1 plus the square root of that, and then check what that is. So let's see it. 3.294 and so on. Okay, so rounded, I guess they said to the 10th. So if you would round to the 10th, that's what it would have been approximately. Now, I guess maybe this will be the last one, but I'll graph so this for you so that you can see it, okay, for yourself on decimals. So I'll take the left-hand side and then the right-hand side and then graph it on decimals, okay? Be right back. All right, so here's the graph. So I took the left-hand side, I graphed it, so notice that's the blue, and then the right-hand side was just log of base 5 of 25, which is equal to 2, so I just plotted the 2 straight across, and notice the intersecting point, which is right here, which indeed is 3.294, so approximately 3.3. So that's exactly what you can do, and that's the meaning. You know, graphing these things and taking left-hand sides and right-hand sides is kind of useful to know, because ultimately that's what it is, right? We're trying to find an x where these functions are intersecting somewhere. And notice they won't intersect on the left-hand side because our log, okay, so as you can see there, okay, it's basically just kind of going up, and it has that restriction, okay, being greater than 0. All right, let's take a look at the next set of questions. All right, so for this example, we'll start off kind of like the others. So the first thing that we'll do is we just have to make sure that we're taking a log of something that is positive. So when we're going to be solving for our x, we have to know that this right here has to be greater than 0. Now, this one isn't as easy to try to figure out, well, because it's a root. Now, I can try to solve this. You don't always have to solve it unless your teachers kind of really tell you to do that, or you're stuck at a situation where you really want to know what the admissible kind of possibilities are. I will solve this for you, okay, just so that you can see what it is. So now, if I take if I want to get rid of the square root, I'm going to square both sides. If I square both sides, I'm going to just get this, because the square of 0 is still 0. Now, this may not always help me as much, but now I have a quadratic on the left-hand side. And actually, it's an inequality. So a quadratic means that it's some kind of a parabola. You'll remember that quadratics kind of look like this, either up or down. This one's going to look up, because I can see that the a is positive here. So this brings you back, right, to quadratics and then understanding them. So I can leave it here, and then when I solve my equation, I can come back to it, substitute my x, and then see if it's still equal to 0. The left-hand side is, greater than 0. But because I said I would solve it, and it's a quadratic. Quadratics are not very hard to try to solve. I'm actually going to complete the square here. So x squared plus 4x, and then completing the square. So dividing the 4 by 2 is going to be 2 squared minus 2 squared. So I basically have this. Now, why am I completing the square? Because I want to know exactly where that parabola is located. And then I can tell, when the left-hand side is greater than 0. That's why I'm actually completing the square here. So if I complete the square, I'm going to get x plus 2 squared minus 2. So this is going to be that. So now this parabola is easy to try to figure out. So now I'm going to just sketch it for us here. So that's x, that's y. So that's a parabola, and the vertex is exactly at, okay? So notice that it shifts over at -2, -4. So -2, -4. So this parabola is going to look something like this. Now, where does it cross 0? That's exactly the x-intercepts there, but that I can tell. So notice that from here, x squared plus 4x. Okay, so this, if I factor this out, this is just that. So my zeros, so So right here, so my zeros, one is at 0, so I guess that's this right here, and then the other one's at -4. And now my left-hand side, so this, when is this greater than 0? Well, it's greater than 0 here, and it's greater than 0 here. So that means x has to be, I guess, less than -4, and then x has to be greater than 0. So those are my admissible ranges. All right, so it can't be kind of stuck there in the middle because I'm not going to get an admissible answer to this log. All right, so now taking this back, I'm going to copy it. Let's solve it and then see if my answers actually fall in that range. Okay, so first thing is first. Okay, so let's actually, okay, so I'm going to raise everything to the 2, to the base 2. So log of 2, I mean, you can kind of, you recognize this now already, I hope. So this means that I'm going to have this equals to that. Now, squaring both sides. So again, so it's going to be x squared plus 4x, and squaring the other side. So, so if I square this, because that's what I'm doing to both sides, then this is just going to be 2, because this is a half times 2 is 1. So really what I have is this. So that means now again I have a quadratic, which looks like this, okay, equals to 0. And now, we can just check, okay, is this possible? Is this not possible? Okay, or whatever that might be. Now, I've actually technically, so this right here, I already know that this, what kind of parabola was that? And then 2, okay, is going to be a flat line there. So this is actually a flat line. So, I mean, if I went back here, to this original, so this is 2. So it's going to look something like that. So that means I will have 2 admissible answers to this. One is going to be greater than 0. One is going to be less than -4, it looks like. Okay. Now I can solve this. And again, I mean, you can try to solve it any way that you like. I'm just going to go ahead and I'll fast forward. I'll just use the quadratic formula because it doesn't pop out at me. I don't like that -2, and it's probably going to be some kind of a long decimal that I'm going to worry about. Okay, so what do I have? All right, so here are your answers, and indeed, so they're both admissible. So notice less than -4 and then greater than 0. Now you can round them off, okay, if they wanted you to round. So this was a great question, actually, because it kind of really forces you to understand, the admissible ranges that you might have. Okay, let's take a look at another example. So here's the next example that we have. It's not the nicest, but let's take a look and see. So again, so first things first, we got to worry about all of these because I have x now everywhere. So from here, 10x plus 10 has to be greater than 0. So that means 10x is greater than, so this will be -1. So that's from right there. From right here, we have x minus 5 has to be greater than 0. So x has to be greater than 5. And then finally from here, we have x plus 5 has to be greater than 0. So x has to be greater than -5. And now notice, so it's all greater than. And that means, okay, so this right here. So x has to be greater than 5. Okay, so that's something that we're going to be searching for in terms of our admissible solution to the equation. Now I have a log, so it's going to be all log of base 10 here. I'm going to combine these together actually. So log, and that's going to be, now I'm going to take that thing out. So 10, this is x plus 1. So I factored out that, divided by, using the property, x minus 5. Okay, so I'm using property for the subtraction under the same base for logs. It's going to be on the left-hand side. Now on the right-hand side, I have log of x plus 5. Now taking and raising it to, to the 10. Okay, so that means that now I'm going to have, so 10x plus 1 all over x minus 5 equals, and this is going to be x plus 5. All right. So now, what do we do here? So this isn't the greatest thing to have. Now we do have, I guess, a problem because notice we have x minus 5 in the denominator. So I guess technically x can't really be, 5, but we already knew that, because that's from our admissible range right here. So that's fine. So now solving this, I'm going to multiply both sides by x minus 5. Because I want to get rid of that thing from the denominator. So that's there. So I have 10. And so here, so multiplication of these, this is actually a difference of squares. It's going to be x squared minus 25. That's a difference of squares there. So you're using a lot of tools from quadratics and others to solve these things. And so now, I guess we're stuck again. I guess I'm going to put this back in here because we have another quadratic. Okay, so I'm going to bring everything to one side. So let's bring all of these guys over. So x squared, and I'm going to bring in minus 10x, minus 10, minus 25. I just brought those over to the right. Collecting here, so x squared minus 10x minus 35 equals 0. So again, we're solving another quadratic. Okay, so we have to solve this quadratic for x to be able to see what the solution actually is. So let me do that, and I'm going to use quadratic, just quadratic formula, okay, just so that it's a little bit quicker. All right, so here we are. I guess we have two solutions again, so taking the positive and then taking this. Now, this is going to give us a negative answer, so we know that we have to be greater than 5. So, you can evaluate it, I guess. Now, how do I know it's a negative answer? Because 10 minus the square root of 240. Okay, so, 240 is bigger than 10. Right? Or 100, sorry. 240 is bigger than 100. So therefore it's going to be bigger than 10 for sure. Okay, so here, so it's about 15 point. So notice 10 minus that, it's going to be a negative answer. So I'm not going to waste my time here. So that won't work. That's not an admissible answer. So that means this is the only admissible answer we have. And so for that, so it's 10 plus, I should have kept it, 240. And that answer is divided by 2. So the answer is approximately this. And again, you can round it to the 10th, which would be 12.7. And that's what you would have had for this example. So I'm not going to graph here. You can graph it if you like and then see if it works out for you. Okay. Let's do the next example, last one. Here's the last example. So I guess another challenge. Let's take a look and see. The only worry we have here, so x only appears here, so that means this x squared has to be greater than 0, which means that x has to be greater than 0, right? So that's what we would have in here. Actually, hold on a second, because x squared, okay, so if we're assuming that it's always positive, okay, so x squared actually, so any number that you put in here is going to be greater than 0 except 0 itself, right? Because if it's a negative x, then what you have is, and you square a negative number, you're still going to get a positive number. So this is not true. Okay, this means that x just cannot be equal to 0. That's the only kind of non-admissible thing that we can have. Okay, so let's solve it. So what do we have in here? I'm going to try, so 3 plus log x squared. I can't really do anything there. Just looking here. Okay, so this is going to be, I'm using the properties here. So 8, I'm going to bring back that 2 minus, okay, so it's going to, let's put this log, it's going to be 2 of 2. So I'm using the property, so bringing it back, okay, as the exponent. Actually, so log 8 squared divided by 2 squared. So again, that's another property. Well, this is just going to be a number. So regardless, I mean, we could have evaluated this anyways. What is this? This is 64 over 4. So I'm going to get, we can simplify this because that 4 goes into 64, what, 16 times? 1, yeah. So this is really just log of 16 on the right-hand side. 3 log x squared. Let's bring this over to the other side. So log, this is going to be log of 16 minus 3. Okay, I can evaluate whatever that is on the right hand side. So log of 16 minus 3. Okay, so it's actually some negative answer here. Okay, so we're going to have negative 1.79. I'm going to keep all of them. I don't want to round these off because this is not the final answer. Now, this probably might still continue, but I guess this many decimals should be enough. So that's going to be log x squared. I'm going to keep that. Now, okay, so I'm going to raise everything to the, so 10. I'm going to create a new base. So that's going to bring down the x squared. So it's going to be 10 to the negative 1.79588 and so on. That's just a number. And now taking square root of both sides, so x equals, so if you take the square root of this junk, whatever that might be, of course it's going to be both positive and negative. And since they're both admissible, I guess you can use both in this case. So whatever this number is, so let's see that. I wish I could, that's okay. Okay, so we're going to take the square root, and that's going to be of 10 to the negative, I'm going to put all that stuff in here, 1.795888017. I mean, probably overkilling this, but that's okay. So plus minus 0.12649 and so on, and you can round as needed. And that's how you would solve this one. So solving these equations where there's logs involved and your unknown is within the log, it's not always that fun, okay, as you can see. And if you understood these 5 examples, incredible, okay, so amazing. Okay, so thanks for watching. Let me know in the comments if you found it useful, and we'll see you in a future video. Bye, everybody. Cheers.